Welcome back, boys. We are going to start our second to last chapter, which is chapter 8. It's on quadratic functions. And basically, the last two chapters of Algebra 1 do deal with quadratic functions. But you will see actually a few things in these last chapters that you should connect to previous chapters that you have learned this year. Now, this video on 8.1 actually will be 15 minutes because that's all that this software allows me. So I will say that I'm going to have to make a short video that has my two examples that should only be about 5 minutes. So you will have to watch another video after this. So this 8.1 lesson talks about how to graph quadratic functions. However, we're not going to graph just yet. You're going to learn some characteristics of what a quadratic function is. So quadratic, you have definitely heard me say in class before, but functions you should remember because I taught them to you in chapter 3, which I know was a very long time ago. And of course, you probably forgot everything, so I'm going to just refresh your memory with what a function is, because if you don't know what it is, you're not going to know what a quadratic function is, obviously. So here we go. So this was some vocab you should remember. You learned what a relation was, which paired inputs with outputs. Then when a relation is given as ordered pairs, the x coordinates were your inputs, and then your y coordinates were your outputs. Now, if every input had exactly one output, then it was called a function. And I went over with you what a birthday function was that you can only have one birthday, and no, half birthdays do not count. So you would have an arrow being drawn from you as the input value to your birthday, which is your output value. Now, obviously, another person could have the same birthday, so you could have two arrows that were being drawn to your birthday, but you would only have one arrow from you being drawn to a birthday in the output section. And then these were all the several ways to describe a function. We described it as an equation, an input-output table, which you're going to see again later on, the mapping diagram, which is kind of what I described with your birthday function example, a graph, a set of ordered pairs, and then using words. And you should remember the vertical line test. That was a test that you used to see if a graph was a function or not. So if you looked at this example, this blue line, if you were to connect these blue dots, would be a function because it would pass the vertical line test, meaning that the red line only went through one blue dot right here. And then this graph over here is not a function because the red line crosses this blue graph at 2 spots. Something else you should remember is domain and range. Domain was the set of all of the possible input values, which were all of your x values, which were your independent variable. And then your range were all of your y values, which were your dependent variable. And I think I forgot to say output values. So output values were your y values, and they were your dependent variable. Okay, so these were some examples from before. So, and you will have to remember how to do domain and range, so you might want to pay attention. So domain, if you remember, were your x values, and I had you list them. So if you look at this graph, you have 4 points on here. This point right here is what? -3, -2. So this is the x value. So you did -3, comma. This point right here was -1, 0. Let me fix that real fast. Was -1, 0. So -1. This point right here was 1, 2. So 1. This point up here was 3, 4. So if you notice, all of these values I just wrote down were all of the x values. Now the domain values, the range values were all of the y values. So same points, but -2, 0, 2, and then 4. Okay, and when I got all these numbers from the ordered pairs. Now this was the easy example. Letter B was the harder one that I gave you in class. Now, this graph should look familiar to you and pretty much what this entire chapter is all about. So if you look at this again, domain would be your x's and range would be your y's. Now, I want you to focus on these 2 points right here. This is -1, 1. This is what? 3, 2. So this is my x value. This is my x value. This is my lowest x value, okay, because my graph is stopping there. That's what the dot means. This 3 is the highest x value, okay? So we put an x in the middle. We put -1 and 3, lowest and highest, and then we had less than or equal to's. So meaning that all of these x values in between are represented between -1 and 3. And then the range were all your y values. So this down here is your lowest y value. It's on the y-axis. So that is what? 1, -3. So this right here, -3 is the lowest y value of your graph. Now your highest y value is actually this point up here. It's your highest point, and the highest y value was 2. Okay, but we used y now, and it was still less than or equal to. So you're going to have to remember how to do domain and range for this lesson. Then we talked about what it meant to be linear or nonlinear. So a linear equation was an equation that could be in slope-intercept form, and that was y equals mx plus b. And then obviously, if it was a linear equation, it was a line, and it represents then a linear function. And linear functions had these constant rates of change, but a non-linear function did not have this constant rate of change, so therefore it was not a line. So these were 2 examples that you learned in chapter 3. So does the graph represent a linear or non-linear function? Obviously, letter A is linear. It is a line, but letter B is non-linear because it was not a line, and I told you that it was a parabola. This is what this entire chapter is all about. This is a quadratic function, and is otherwise known as a parabola. So you're going to see several of these U-shaped graphs, and they are called parabolas. So that should all have been a review. And let's get on to the new material. So I'm just going to warn you, there's lots of vocab with this lesson. So a blank blank is a nonlinear function that can be written in the standard form of y equals ax squared plus bx plus c, where a is not equal to 0. This right here should look super familiar to you because that is when we did our slide and divide, our a times c method, all of that. And that worked for quadratic equations, but we're going to talk about quadratic functions. And if you remember, a quadratic does not mean 4 in math. Quadratic meant the x squared. And then the second vocab word is quadratic functions are U-shaped graphs, otherwise known as parabolas. And you will see 2 different kinds of parabolas. You will see happy parabolas, or you will see sad parabolas. You will not see sideways parabolas. We're not going to do those. So you only have 2 options, okay? Happy-faced or frowny-faced parabolas. Now, this I took from your book. This is going to explain a little bit of the different characteristics of a quadratic function. Now, this might seem overwhelming to you, so I'm going to kind of break it down vocab word by vocab word to kind of, lessen the blow to you. But this word here vertex and this word here, axis of symmetry, you will learn. I'm just going to make it simpler for you. So this graph you see here is the parent function of a quadratic function. Okay, so parent means obviously the head, and this is what it is. It is f of x equals x squared. Okay, and just to clarify that the f of x notation was just another name for y. Okay, so this is the main function that you're going to see. Now, if I were to add different numbers to that function, then it wouldn't be the parent function. It would be like the offspring. Okay, so that's what you're going to do later on, but not today. Now, if you notice, your a was 1, obviously right here, and your b and c are all equal to 0, because clearly you don't see them in this function. Okay, so this is our parabola. This is our parent parabola. The parent parabola always goes through 0, 0. Okay, and then obviously it goes through several other points. Okay, now the most important point of this parent function, and pretty much of any quadratic function, is the vertex. And the vertex is the lowest or minimum point or the highest maximum point of the graph. So this right here, 0, 0, is known as your vertex. Okay, now it's a maximum if it's at the top of your U, which obviously this is not. We don't have the top of our U, we have a bottom of the U, so this vertex would be a minimum point, and it's always in the form of x comma y. Now, same picture again, but new vocab word is what this axis of symmetry is. So if I were to draw a vertical line that goes through, that goes through my vertex, it would cut my graph in half symmetrically. So the axis of symmetry is the vertical line that divides the parabola into two symmetric parts, okay? Meaning that this red part of my graph would match with this red part of my graph, okay? And every quadratic function has one, and it always goes through your vertex. But it's actually an equation, and it's actually the x value of your vertex. So this, if you look at your vertex, it's x comma y. So the axis of symmetry would be x equals 0. So you never have to actually find it. You just need to find your vertex, draw your dotted line, and give me the x value. But make sure it's an x equals. And then you have a different looking graph. You have your axis of symmetry, or otherwise known as just line of symmetry. You have your vertex down here, but then you have another vocab word, x-intercepts, which you should remember. X-intercepts are where your graph crosses or touches your x-axis. Now, some other words for x-intercepts are roots, zeros, or solutions. Okay, so all of those words mean x-intercepts. Okay, now for your purposes, I'm going to make them all be whole numbers, so I'm not going to have you do, decimals or fractions. So if you look right here, this and this would be your x-intercepts, and they would be in the form of a point. So that one would be -1, 0. This one would be 3, 0. And generally, you would have 2 x-intercepts, but sometimes you could have 1 or even none. And the last slide before I close this video is this is a labeled quadratic formula. So obviously up here, you have your axis of symmetry. You have your vertex, which is right here. It's a minimum because it's your lowest. And then you have your roots, which are also called your x-intercepts, okay? So I'm going to do one more short video, which has my examples, which will help you on your homework.